Let's quickly peruse the student data. So here you see the data table. This is what you, when you enter your form information for your AERY number, your average distance, and your maximum distance, this is where it's going. And just looking at this pile of numbers really doesn't make any sense. But if we look at the class data, then you can see that I've got an average for each group, a max for each group, and a standard deviation. Standard deviation numbers are just telling us these numbers are all over the place. So we see that the average AERY is about 160, the average distance is about 40, and the maximum average distance is about 60. And I capped it off with the testing environment we were in. We did have planes that were exceeding this distance, but I capped it at 100. And you can see we have several planes that hit 100 feet. Okay. The side to side in our gymnasium was 86 feet, and we had several hit that, and then some that would fly diagonally from one corner to the other. So if you can fly more than 100 feet, then that's good for you. And then you can also see the maximum numbers we have here, 240 for AERY. The maximum average distance was 83. What happened a lot with this one is it took them a bit to dial in. So they had a lot of disqualified flights where it was hitting the walls or furniture. So, and then the maximum distance that I capped it at is 100. And you can see we have 3 airplanes that did that. One almost did that. So let's look at this chart. So we have two things. So we are looking at distance versus the AERY number. AERY number is across the bottom. Distance is on the y-axis. So as we increase AERY, do we see a general trend? Not really. Look at these numbers. They're all over the place. If you look at the average, the blue ones, that's really what's most interesting to us because that's typical performance. As you increase the AERY number, it's not really changing much. The average is staying around in here. There's a little bit of increase maybe if you go this way, but it's not real evidence. So ideally what you would want to see is a nice linear increase or decrease. So if you increase the AERY number, they are kind of generally going this way. But if you look at this, we have some of the lowest AERY numbers and some of the highest AERY numbers that resulted with the best flights. And we have some numbers that are pretty high that didn't do as well. So AERY number really doesn't say anything. Really what I'm going to tell students next year, if your AERY number is about 160 plus or minus about 30, you're probably in good shape to make an airplane that flies. And then really it comes down to a lot of human factors. There is a big gap between designing an airplane that is perfect in software and actually constructing that aircraft perfectly. So a lot of what we're seeing here, a lot of variation is from the construction of the airplane itself and mistakes that were made or things that were done exactly right, and then dialing in the flight itself. That's why I wanted you to do so many flights so we could get it dialed in. We did have several planes where it took about 12 or 13 flights before they started getting it to go straight and level. So that's a little bit about AERY analysis and looking at your class data. So these numbers are going to change based on what you guys put in. So give me the real numbers. You can use these to substantiate claims like my aircraft performed better than most or worse than most, and you can give me actual numbers using this data. So that's all I have to say. Thank you.